Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Microprocessor and Microcontrollers, which comes in third year, sixth semester. Today we are going to start our chapter number 2, that is 8085 Microprocessor Architecture. And this is the module number 1 for chapter number 2. So this is the module number 2.1. So let's start with the features of 8085. In this video lecture we are going to see the features of 8085. So 8085 is a 8-bit microprocessor suitable for a wide range of applications. It is a single chip and most device implemented with approximately 6200 transistor on a 164 by 222 milli chip contained in 40 pin dual inline package. So we already know that microprocessor is work based on the transistor, so we can also call as a transistor logic. So microprocessor or microcontroller is going to work on the base of transistor logic. And in 8085 microprocessor we have 6200 transistor connected in 164 by 222 milli chip containing 40 different number of pins. Now we are going to use all these 40 number of pins in different order, or we can say we can group it in different order to perform different functions. So now let's see the features first of all. So the features of 8085 includes the first one, that is it is an 8-bit microprocessor, that is it can accept, process or provide 8-bit data simultaneously. So we know that the microprocessor 8085 is 8-bit microprocessor, so it can accept, process and provide 8-bit data simultaneously. So we can also program it in 8-bit controller. Okay, now it operate on a single 5-volt power supply. This is also the one feature of 8085, that it is going to operate on single 5-volt power supply connected as VCC power supply, and ground is connected at VSS. So we have two different pins, that is VCC and VSS. So we are going to connect our plus 5 volt at a point of VCC, and ground pin is connected at VSS. This is what we are going to see in the next video lecture, that is the pin configuration of 8085. But right now this is the basic fundamental that we can operate our microprocessor 8085 with the help of 5-volt power supply. Now third one, that is it operate on clock cycle with 50 percentage duty. Now what is duty cycle? Duty cycle is turn on time divided by the total time. So our microprocessor is going to work on 50 percentage. So 50 percentage time is on time and 100 percentage time, that is the total time. So turn on time of the processor is we can call as a 50 percentage. Next we are going to see it has on chip clock generator. Okay, it has on chip clock generator, so we do not need to give any external supply or an external clock signal to the controller or to the processor. So it has its clock signal generator on inbuilt. This internal clock generator required tune circuit. So always we need to remember that the clock generator required to tune circuit, that is LC circuit or RC circuit or crystal circuit, that is for tuning the frequency or tuning the clock signals of that processor. Now the internal clock generator divides oscillators frequency by 2 and generate clock signals, which can be used for synchronizing external device. So whenever we are synchronizing our processor with the external device, at that time we need to compare, or we can say we need to synchronize both the clock signal, both the clock frequencies with each other. So that's why we can synchronize the external device with our microprocessor. Now fifth one, that is it can operate with 3 megahertz clock frequency. The 8085A2, that is the version 2, can operate at a maximum frequency of 5 megahertz. So we can easily say that higher the frequency rate, the faster our microprocessor is going to be work. So if our microprocessor is going to work on lesser frequency, at that time the speed of response is going to be reduced. and if the frequency of the microprocessor is going to be increased, at that time the speed of processor is going to be decrease. Okay, so few speed efficient, that's why we require higher efficiency. Now 6.1, that is it has 16 address line, hence it can access 216, that is 64 kilobytes of memory. 7th, it provide 8-bit input output address to access 28, that is 256 input output ports. Okay, next one, that is in 8085 the lower 8-bit address, that is A0 to A7, that is 8-bit address lower address bus and data address bus, that are D0 to D7, are multiplexed to reduce the number of external pins. Okay, both are multiplexed to reduce the number of external pins. This you need to remember this term. But due to this, external hardware, that is latch, is required to separate address line and data line. So latch is required to separate what? Separate address line and separate data line. Now next 9 we are going to see. It supports 74 instruction with the following addressing mode. So here are addressing mode, that are immediate addressing mode, then after register, then after direct, indirect and implied. Then after 10th, that is arithmetic and logical unit. We already studied about ALU in 8085, right? So which type of function we can perform with the help of ALU, that is 8-bit binary addition with or without carry, then after 16-bit binary addition, then after 2-digit BCD addition, then after 8-bit subtraction with or without borrow. We can perform both with or without borrow, and 8-bit logical and or XOR complement, that is not, and bit shift operation. We can perform all this with the help of arithmetic and logic unit in 8085. Now next one, that is it has 8-bit accumulator, flag register, instruction register, 6 8-bit general purpose register, that are 6 8-bit general purpose register, that are B, C, D, E, H and L. These are the 6 8-bit general purpose register that are going to perform, or that are going to be operate with the help of different instructions, and two 16-bit operators. So two 16-bit operator, that are SP, that is stack pointer, and PC, that is program counter. Okay, so these two are 16-bit operators and all these 6 are 8-bit operators. Okay, 8-bit general purpose register. We are going to see this in detail in next lesson, but right now we need to remember it. It is 8-bit, and over here, that is stack pointer, SP, and PC, that is program counter, are 16-bit register. Getting the operand from the general purpose register is more faster from the memory. Hence, skilled programmer always perform general purpose register to store program variables than in memory. So whenever we are going to store variables, we are going to store variables in general purpose register, because it is faster to take that memory from the locations, okay, rather than the permanent or variable memory. Next, it provides 5 hardware interrupts that are TRAP, that is TRAP, then after RST 7.5, RST 6.5, RST 5.5 and INTR. These are the interrupts that are externally interrupt the hardware. Then after, it has serial input output control, which allows serial communication. So whenever we are going to communicate our microprocessor with something like GSM modem, at that time we are going to use the serial communication pins. Okay, then after, it provide control signals, that is input output memory read and write, RD, that is read, and WR, that is write, to control the bus cycles, and hence external bus control is required. 15, the external hardware, that is another microprocessor or equivalent master, can detect which machine cycles microprocessor is executing using the status signal. So whenever we have a different microprocessor, let's say we have 2 or 3 microprocessor, at that time the status signal is going to be given to the microprocessor, either it is going to perform the execution or not. So for that, input output or memory, that is S0 and S1. This feature is very useful when more than one processor are using commonly system resource, that is memory and input output device. So whenever we are using more than one microprocessor, at that time we are going to give external command, that is S0 or S1, that which microprocessors need to execute which type of operations. 16, that is, it has a mechanism by which it is possible to increase its interrupt handling capacity. 17th, the 8085 has the ability to share system bus with direct memory access controllers. This feature allows the transfer large amount of data from input output device to the memory, or from memory to input output device with the high speed. Okay, so it has high speed ability. And 18, that is, it can be used to implement 3 clip microprocessor with supporting input output device like IC 81555, 8155 and IC 8355. That's it. And here are the question from the GTU examination that are already asked in GTU examination. So please note this down. These questions are covered in this video lecture. So if you have any kind of query regarding this session, then please ask me in comment section. Thank you.